This is your video for section 7.2. In this one, we're going to talk about another case where we can use the law of sines. This one is called the ambiguous case. This is the one that we mentioned in section 7.1, where it can turn out that there are actually two possible triangles. It can also turn out that there's one possible triangle or that there's no possible triangle in this case. This is the case where we have side-side angle. We have two sides and we have an angle, but the angle is not the one that's included between the two sides. On this first page of the notes, we've got several different possibilities. You don't need to memorize these because there are really easier ways to figure out whether you've got no triangle or one triangle or two triangles. But we're just going to talk about each different situation. For our first possibility, our angle A is acute. And in all of these, we're assuming that A is the angle that's at the bottom left of our picture. This is the case where there are no possible triangles. And that is because if you draw the triangle this way, it turns out that side A is too short to reach down to the bottom of the triangle. So this one is when side A is shorter than side B, and side A is also shorter than the height of the triangle. What really tells you in this one that there's no possible triangle is that when you try to use the law of sines and solve for angle B, which would be over here, it turns out that the sine of B is greater than 1. That's not possible, which means there's no solution and there's no possible triangle. The next case is when angle A is acute. This is when there's one possible triangle, and this is actually when you have a right triangle. Side A is the same as the height of the triangle. This is another one where the A is actually less than the B. And in this one, when you try to solve for angle B, it turns out that the sine of B is actually equal to 1. Where that happens is if B is 90 degrees. The third one is when A is acute. This is also a one triangle situation. And this is when A is greater than or equal to B. So we've got a long side A over here. When we try to solve for the sine of B, it turns out that the sine of B is less than 1. The last possibility, if A is an acute angle, is that we get two possible triangles. This is where the A could either be swinging this direction or it could be swinging this direction. So there are two possible places that side A could be, which means that there are two possibilities for angle B. So we've got a B1 and a B2. In this one, the A is less than the B. The sine of B1 over here turns out to be less than 1. B1 and the B2 are supplementary. So what has to happen is if you figure out your B2, then the B2 plus the A has to be less than 180 degrees so that you can get an actual triangle here. So the A angle plus the B2 is less than 180 degrees. Now there are also two possibilities if A is an obtuse angle, meaning that it's more than 90 degrees. The first one gives us no triangle. This is if the A is less than or equal to the B, which means that we wouldn't be able to get the A to reach down to the side of the triangle. If you have this situation, your sine of B will turn out to be greater than or equal to 1. Then the last one is if A is an obtuse angle. In this one, we do get one triangle. This is where the A is greater than the B, and the sine of B turns out to be less than 1. Now, some people try to memorize all these different possibilities, whether the A is less than the B or greater than or the B. I don't try to do that. I just go through and solve for the sine of B. If it turns out that the sine of B is greater than 1, I know I've got no solution, no triangle. If the sine of B is less than 1, then I might have one triangle or two triangles. Here's some tips from the textbook for applying the law of sines in these situations. Since we've got angles in a triangle, we're not talking about angles in the third or fourth quadrant. That means that the sine of theta always has to be something between 0 and 1. If the sine theta turns out to be exactly 1, then our angle is 90 degrees and we have a right triangle. Another fact is that the sine of theta is the same as the sine of 180 degrees minus theta. These two would be supplementary angles. In the case where you have two triangles, you end up with the B1 and the B2 being supplementary angles, and they have the same sine value. The third tip here is what we talked about in the last section. In a triangle, the smallest angle has to be opposite the shortest side. The largest angle has to be opposite the longest side. I'm going to add another tip on here. In the problems that we do, we don't always have the sides and angles with the same letters that they were in the examples on the previous page. The easiest way to do this is to always draw your triangle the same. So what I do is draw my triangle so that the given angle is at the bottom left and the other side that you're given is on the left. That way your triangle will always look the same regardless of what the different angles and sides are labeled as. So in this first example, we don't have our given angle labeled as A, so we're going to use this tip right away. But what I'm going to do is that since my given angle is angle B, I'm going to make that one the one at the bottom left of my triangle. I always draw these so I've got a horizontal base, and then my given angle is going to be the one right here. This is going to be my 55 degrees 40 minutes, and that's angle B. That means that my side B is going to be the one over here across from that angle. And I'm going to put my other side that I know at the left of my picture. So I'm going to make this the A over here. And what I want to do with these is I want to solve for this angle. I want to put my given angle at the bottom left. I want to solve for the angle that would be at the bottom right of my triangle. To do that, I'm going to use the law of sines. I have this side and the angle across from it. I want to solve for this angle. I'm going to use this side. So the length of side A, and then down here I'm going to have the sine of A. First thing I would have to do with this equation is solve for the sine of A. To do that, I'm actually going to cross multiply this. Then I want to solve for the sine of A, so I'm going to divide both sides by the 8.94. Now when I divide this, I end up with the sine of A equals 2.3. This is the point that you can tell right away if it's the case that there's no triangle. If the sine of your angle comes out to be greater than 1, that's not possible, and that's what happened here. Right away we know that there is no such triangle. This is not possible because the sine of A came out to be greater than 1. There's no triangle that would fit this situation. What's happening in our picture here is that this side is actually too short to come down and meet the base of the triangle. Let's look at another example. This time my given angle is A. Again, I'm going to put that on this side. That means that my side over here is going to be side A. And I'm going to put my other given side over here at the left. What I'm trying to solve for is this angle over here, which would be angle C. I'm going to use A over sine of A equals C over sine of C. I'm going to solve this equation for the sine of C. I'm cross multiplying. And then I'm going to divide both sides by the 10.7. That gives me 0.46319 approximately for the sine of C. This one is going to have at least one triangle because my sine did come out to be smaller than 1. To find angle C, I'm going to use the inverse sine on my calculator. Remember, for this, you have to have your calculator in degree mode so that you get your angle in degrees. And this turns out to be 27.6 degrees. So that's my C. Now I'm going to label this C1 because at this point I don't know if I've only got one triangle or if I have two triangles. So I'm going to say that that's C1. I want to check and see if it's possible to have another triangle. What I'm going to do for that is I'm going to find the supplementary angle to this one. That would be my C2. That would equal 152.4 degrees. So if this is happening, what it would mean is that I've got my A either going this way or swinging over this way. So I'd have my C1 over here and my C2 over here would be a supplementary angle. Now to see if this is possible, what I need to see is if this little triangle right here is possible. If my C2 and my A add up to more than 180 degrees, then I can't get a triangle that way. So what I want to do now is add up my C2 and my angle A. That actually adds up to 195.9 degrees. That's greater than 180 degrees, so I can't get a triangle there. That tells me there is no second triangle. I just have the one triangle. So I've already got the angle for this one. This is going to be 27.6 degrees. Now I've got side A and angle A, and I've got side C and angle C. I still need angle B and I need side B. To get angle B, I'm going to take these two and add them together and then subtract from 180. Angle A and angle C added together is 71.1 degrees. When I subtract that from 180, I get 108.9 degrees. That's my angle B. Now I can find side B using the law of sines. I'm going to take the two values I was given, which were side A and angle A, and use that on one side of my proportion. And then I'm solving for side B, and I'm going to use angle B here. All I have to do to solve this for B is multiply both sides by the sine of 108.9. When I do that, if I round to one decimal place, I get 14.7. That means my side B would be 14.7 inches.